We're going to take a look at an IV push problem. Let's look at the important information that is given to us. The medication is ordered, the name of the med is here, and the amount, 1 milligram, is an IV push. The strength, we see that the name of the med matches, and we have 5 milligrams per milliliter. And directions were to dilute with normal saline for a total of 0.25 milligrams per milliliter, and it also gives us an administration time of 2 minutes. Our first question, how many milliliters of the med will you need? So we have an ordered amount of 1 milligram, and we had a strength that had 5 milligrams, and I'm setting up dimensional analysis, so I'm putting the milligrams in the denominator. Those 5 milligrams were in 1 milliliter. So doing my math, 1 divided by 5, I end up with 0.2 mLs of the med. Next question, how many milliliters of normal saline should you add? So to do this question, I'm going to use the information from the directions, which says we should have a concentration of 0.25 milligrams to 1 milliliter. I want to keep that concentration, so I'm going to actually use a different setup. I'm not using dimensional analysis here, but I'm going to use the idea of a proportion. I want to keep that strength. I want to give 1 milligram, and so I want to know how many milliliters are required. When I use the equal sign between my fractions, I set my fractions up so that the labels match, because I truly want equal fractions. And when I solve this, I have to multiply on the diagonals. So when I multiply, I get 1 is equal to 0.25x. To get my x by itself, I'll divide by 0.25 on both sides. And from that, I get x equals 4 mLs. So that tells me that there should be a total of 4 mLs for this particular IV push. However, up here I already calculated that 0.2 of those mLs should be the medication. So I'm going to take the 4 total and subtract out the 0.2 to find that I should have 3.8 mLs of the normal saline. Now, I could have set up this problem using the dimensional analysis as well, and so let me show you that. We have an order of 1 milligram, and we have a strength of 0.25 milligrams per ml. So if I do this math, I have the answer of 4 mLs again. I like to set this up with the proportion first because it emphasizes the idea that I want to keep that strength, that I have the equal fractions. Truly, the dimensional analysis does the same thing of canceling the label of milligrams, and so if you normally use dimensional analysis, you can stick with that method. Either way, we have to go back and subtract the med from that total, and that's how we end up with the 3.8 mLs of normal saline. Now it asks me at what ml per minute rate should the med be administered. Well, we know that in our syringe we would have a total volume of 4 milliliters. Some of that's the medication, some of that's the normal saline. At the beginning, we noted in the problem the directions said to administer over 2 minutes. So I'll divide that by 2 minutes, and I end up with 2 milliliters per minute. Last thing that I'm asked is about a 15-second rate. And I know that 15 seconds is the same as 1/4 minute. So I literally am going to take my answer from the previous question and divide it by 4 to get 1/4 of a minute. So if I take 2 divided by 4, I get 1/2, so 0.5 mLs are to be administered every 15 seconds. And that will give me something that's much easier to track than the milliliter per minute rate. So I can watch my watch and time out 15 seconds and push a 1/2 milliliter over that duration.